Hey guys, it's Chewy. Just wanted to do a quick little video on bud switches and show you maybe how they work if you don't understand exactly what's going on or what's happening and why it does the things it does. Um, a bud is a block update detection, okay, and what you need is a primed piston or dropper to create a block update detection switch. And the way you would create a primed piston or dropper would be to indirectly power it like that. That piston is powered, but it has nothing nearby to cause a block update to make it go. So let's say if we had a piston here, of course, then that piston would be powered and have an update. Now the top piston is getting an update from the state of the block changing from powered to unpowered. So this piston here gets an update. It gets power and an update. That's what it takes to make a piston work. It's power and an update. So if I take that one out, then the bottom block has power, but it hasn't received an update. And so when it gets an update, then of course it will extend. Now the same thing on the closing side here. There's no power on the block, but it hasn't received an update, so it's still extended. When it receives an update, then it will, retract. The same here. This block is indirectly powered. If I was to put a piston here, then the block would fire every time that the power came on and off. But since it's only indirectly powered, it will only power when, or it will only extend when it has an update nearby. The same with the unextending. This is one mechanic. This is called quasi-connectivity, and the idea here is that the block is indirectly powered and doesn't have a block near it to cause an update to make it go. Now this block here is directly on top of the piston, and what will happen when I throw the switch here is that the block will fire instantly. Now this is the other way that you can create a bud switch, and this is how most of the ones are made. The idea here is that two things are required for this piston to extend. Now it needs power and it needs a block update. So when I power it, it's going to receive power and a block update. But since the piston cannot extend because it can't push this extended piston here, what's going to happen is, okay, it's powered and it gets its update, but it can't extend. Now it's powered, but there's no update telling it that it can move now. There's nothing to update the piston to let it know that it can in fact move now. It doesn't check to see if it can push because there's nothing telling it to check. And then of course when it gets power, then it will extend, of course, or when it gets an update rather. Now we'll move on. This is a self-recycling bud switch here, and what happens is you place a block here or cause a block update to happen adjacent to this piston, and it will push the redstone block over. And what happens is it powers this redstone here, which depowers this torch. What that does is let the when the block update happens, it pushes it over. And what happens is it unpowers this torch and allows this piston to retract, and then it powers this torch, but it's on a delay. So what happens is when the redstone block is pushed back over, this piston is still extended when the lamp comes back on here. When the torch comes back on here, this piston here is still extended, and so it puts it in the state like this here, where it's already been powered, but it can't extend because it hasn't received an update, and that's how this one works. Now the next one here is meant to be a ceiling design. This is something that can fit in your ceiling, and then you could cause a block update underneath it to cause it to go off. Should like right there. And what happens on this one, the way this one works, is this redstone block is indirectly powering this piston. Because there's no update, the piston doesn't detect that it's powered. But when it is powered, it pushes the redstone block up here, runs through the same 3-tick delay like on this one here, and it directly powers this top piston, which pushes it down. Now at this time, the bottom piston is powered and receiving an update, but since this piston here is extended, it can't push it back up, and so it takes it to the state of this one and that, where it has been powered but it couldn't move. Now this one here works on the same mechanic. This is a floor-based design. This is something that you would put in the floor to detect something. And as you can see, we put we'll put a little floor around it here. We can see what's going on. Now this would be a floor design. As you can see, it cycles every time that we cause a block update near it. Whoops, that broke it. Alright, and the way this one works is, of course, when it pushes the block down, when you get an update, it pushes that block down and powers the redstone line. And again, we've got the same mechanic that we've seen before, time and time again. This torch here is unpowered first, which lets the piston retract, and then shortly thereafter, this piston here pushes out. And by the time that this piston retracts, this torch here has already powered the block up here again, and it's missed its chance to extend. And if you watch, it's kind of quick, but you can see what happens. The piston is in the way here when this piston should extend, and therefore it causes the bud situation the same as the last three that we've looked at. Now this one here is kind of interesting. It's a dropper based bud switch. It doesn't make any noise, as you've seen. Every time that this dropper here gets an update next to it, it will cause it to cycle. Now the way this one works is inside the dropper you have items. Doesn't matter how many, you just have to have at least one, and you have nothing in the hopper, of course. And in the normal condition, the hopper is powered, which doesn't allow items to fall out of it. And what happens is this dropper is budded via this block here. This block here having power on it causes this one to be awaiting an update to do what it does. And what happens is when it updates, it spits an item into this hopper, and it momentarily turns off the power. And at the point when it turns off the power, the item slides back into the hopper, and then this power here slides in and feeds underneath the dropper. Now the reason why you need this power at the bottom is because without it, this machine will just clock. What happens is this power here powers the dropper during the time when it's not powered up here. So it primes it and causes it to be ready to go again. This one is silent, doesn't make any noise, and it's really nice. We're going to talk about a few things that can cause pistons to update. Most commonly, it's a block being placed, created, moved, or a piston being moved nearby, like this here. This is a automatic switch. It will send a pulse every time one of these three cactuses grow, and can be used to fully automate various devices without using clocks or timers. And like I said, every time a cactus grows, it would push the block over and cause a redstone pulse to come out on this side. This is another interesting way to trigger a bud switch. A single tripwire like this here, I don't know if you can see it. There's a tripwire right here. Now if you walk through the tripwire, it will trigger the bud switch because the tripwire is looking for whether or not there's entities on it. Whether or not it's connected to the tripwire hooks is irrelevant. It will still cause a block update every time that it's triggered. And you can see I had one here also, I think. Yeah, it works on this one as well. And interesting to note, when you step on the tripwire, it causes an update, and when you step off the tripwire, it also causes an update. A few other things that can cause updates to bud switches: you can run water. When the water reaches near a bud switch, it will cause a block update. Lava will also cause the same thing to happen. Another interesting thing is, even if you already have water there, a change in the flow of the water will cause a block update as well, as you can see there. And then of course removing the water will also cause a block update. Like so, and if you can see, as the water level was changing, it caused multiple pulses to happen. So it's just, you got to keep in mind whenever you're wiring up a device that of the things that you can do with that. Other things that will trigger a block update: a redstone signal changing, will trigger a block update. As you can see, this here has no conceivable way to power that. What it's doing is every time I cause the state of that redstone wire to change, it's going to signal that bud switch. So you could detect when a state changed. You could use this as a monostable. Like, let's say you wanted this to fire on when a circuit turned on, you wanted it to fire, and when it turned off, you could have it fire. Even though it's not directly tied into it, you could use this as a replacement for a monostable. I don't know why you would want to do that, but strange things come up when you're designing redstone. And like I said, I just wanted to share what I know about bud switches and hope that you guys can use it in your designs. Have fun.